Yeah, so we are now working out this example where we have a compound PDF and you are supposed to get its median. So like we said, if it is compound, the first step is to get the median interval, and that is the interval that contains the mode. It will be an interval whose integral from negative infinity to positive infinity is at least half, implying that when you integrate from its lower limit to its upper limit, the result must be a minimum of a half. If you get a half and beyond, then you stop and you say that the median lies there. Now, in our solution, because this time the PDF is not simple and it is compound, we start by testing for the median interval. We are going to test for the median interval. So while testing for the median interval is an interval whose integral from negative infinity to positive infinity of small f of x is at least a half. So you go interval by interval and you check whether it will give you an integral which is either a half or above half. So we are starting with the first step. If this was simple, you go direct to finding the median using the integral from negative infinity. The median of f of x dx is equal to a half. But now it is not a simple PDF, so you must first find out which interval is containing the median. So we are going to say for the interval which runs from -1 up to 0. We are testing that one first to find out whether our median is there. So when we integrate where there is negative infinity, we put the lower limit. Okay. My f of x, let me first identify f of x for that interval. It is a 2/3 x plus 1. This is when x lies between -1 and a 0. So we are going to integrate and find out whether this property is satisfied. And once it is satisfied, it means the median is there and we shall calculate it. So we are quoting this. Where there is negative infinity, we put the lower limit of the interval. Where there is positive infinity, we put the upper limit of the interval. Where there is f of x, you put the function of f of x for that particular interval. So it is a 2/3 into x plus 1 dx. You want the result. Then after getting that result we shall check whether it is either less or greater than a half. And if it is greater than a half, it means the median will be lying there. If it is less than a half, it means the median is not there. So our integral of this is going to be a 2/3, the integral from -1 to 0 of x plus 1 dx. Which is the same as the 2/3, which was a constant. So what do we get when you integrate first x? We get x squared over 2. What do you get? This is for when you integrate x. When you integrate 1, you get x. But we have integrated from -1 up to a 0. Put in the upper limit. We are going to have our 2/3 into. Put in the upper limit, it is a 0 squared over 2 plus 0. So I have substituted in 0 everywhere in this function. Now put in the lower limit, it is going to be a negative 1 squared over 2 plus negative 1, and then you close. So my integral from negative 1 to 0 of 2 over 3 into x plus 1 dx is going to be, it is a 2 over 3. When you work out the first part, it gives a 0. Now minus, this is half minus 1, which is negative half. So minus half, and this will be a 2 over 3 times a 1 over 2 when this becomes positive. So this 2 goes with that, and our integral from negative 1 to 0 of 2 over 3 into x plus 1 dx is going to be a third. Now after getting the integral, you ask yourself, is the answer for this interval greater? Is it equal to a half or greater than a half? If yes, the median lies there. If no, the median does not lie there. Now the other one is a half, it is a third, which is the same as, it is a third, which is the same as 0.3333. Then this half is the same as 0.5. We are looking for an answer which is either 0.5 or greater than 0.5. So we shall conclude and say that since the integral from negative 1 to 0 of 2 over 3 into x plus 1 dx, which is a third, is less than a half, then that interval is not the median interval. It is not the median interval, because the median interval must give that. Then negative 1 is less or equal to x, less or equal to 0, is not the median interval. And since it is not the median interval, then we are going to check for the median in the next interval. So we are now checking for the median in the next interval. So we are testing for the median in the interval from 0 less or equal to x, less or equal to 2. Our f of x was initially, it was a 2 over 3 into x plus 1. This is when x is between 0, negative 1 and 0. It is a 1 over 3 into 2 minus x. This is when x is between 0 and 2, and it is 0 elsewhere. Now we want to test whether the median is in this interval. But because these are continuous random variables, there is no way you can get this interval unless you have passed through this one. You can't skip this and you got this one. But if you want to get here, you must move continuously until when you get there. So you are going to move from this to this, then from this up to that. But our target is to test whether the integral from here up there will give us an answer which is either a half or greater than a half. So when testing for this interval, like we have said, our integral from negative infinity to positive infinity of f of x dx for the median interval should be at least a half. We are testing 0 is less or equal to x, less or equal to 2. But we can't get here unless when we pass through that. So we are going to have the integral from negative 1 to 0 of 2 over 3 into x plus a 1 dx. Eliminate this one also. Now plus the integral from 0 up to a 2 of 1 over 3 into 2 minus x dx. It is this result that we want to generate. But our focus is on testing this, but we can't test this unless we go through that. That is why we are first integrating from this to this, then we get what we want to test. Now this first integral, we have calculated it in the first part, and its result is what? This first integral, we have calculated it in the initial interval, and its result was a third. So where this one is, it is definitely a third. Now we are left with integrating this. So it is a plus, pull out a third. It is the integral from 0 to 2 of 2 minus x dx. So that is going to be equal to a third plus a third. What do you get when you integrate 2? We shall get 2x. What do you get when you integrate minus? What do you get when you integrate x? It is x squared over 2. But we are integrating from a 0 up to a 2. So we shall have a third plus a third. Put in the upper limit. We are going to have a 2 into 2 minus a 2 squared over 2. Now minus, put in the lower limit. It is a 2 into a 0 plus, not plus, minus 0 squared over a 2. So this is the same as a third plus a third into 2 times 2, that is a 4. Then a 4 over 2, that is a 2. So 4 minus a 2, that is a 2, and the other one is a 0. So we shall have a third plus 2 thirds, and the answer is the 1. So let us avoid these open-ended statements. So this is the integral from negative 1 to 0 of 2 over 3 into x plus 1 dx, plus the integral from 0 up to 2 of 1 over 3 into 2 minus x dx is equal to that. Even our final result is an integral of x plus 1 dx plus a third of 2 minus x dx. This is from 0 to 2. And the final answer, there was the 1. So this is a third plus 2 thirds. Now since our final answer is a 1, it means the median lies here, because we're looking for an answer which is either a half or greater than a half. And because the result is a 1, it means that the median lies in this interval. So we are concluding from here that since the integral from negative 1 to 0 of 2 over 3 into x plus 1 dx plus from 0 up to 2 of 1 over 3 into 2 minus x dx is equal to 1, which is greater than a half. Then the median lies in the interval A. You're going to recall that we tested from negative 1 to 0 and it failed. So it definitely means that the median lies in the interval from 0 up to 2. So lies in the interval 0 is also equal to x, this is equal to a 2. And if we let the median to be m, then we now want to find let us first specify what we are doing. After finding the interval, then we are finding the median. So because we are going to find the median, first suppose, so you let m to be the median. And if m is the median, and it is lying in the range from 0 is equal to x, is equal to m, that is the median interval, then we first redefine f of x. Our f of x is 2 over 3 into x plus 1. This is when x lies between -1 and 0, is 1 over 3 into 2 minus x. That is when x lies between 0 and 2, and it is 0. Else where, so our median interval is 0 to 2. So the median is here. We put there n. And because the median is there, we are now going to look for this value of n, which lies between 0 and 2. Now we said when you integrate from negative infinity up to the median value, and you integrate in the PDF with respect to x, the answer should be a half, where our m is the median. Now negative infinity is the lower limit of the interval, but our intervals are stretching from what? -1, because you can't reach this m unless when you go through this one. So we are going to have the integral from -1 up to 0 of 2 over 3 into x plus 1 dx. We have not reached this one. Now plus the integral from 0 up to m of 1 over 3 into 2 minus x dx, and the answer should be a half. Some other legend may choose to take from m to 2 and integrate only this part and equate to what? To a half. It is also right, but we don't want to complicate life. When you integrate from m to 2 and you integrate this one is equal to a half, it gives the same solution as when you integrate from -1 to 0, from 0 to m, and then equate to a half. Because we said initially, we revised what we said, that from negative infinity to m, f of x dx integral is a half. Then from m to infinity, f of x dx integral is also a half. So you can either take from -1 to m or from m to 2, and you get the values of m, but all those parts will be equal to a half, although you have picked what most of the colleagues may understand easily. So negative infinity represents the lower limit, which is a -1, and m is found this side. So how do you move from -1 up to m? You first integrate from -1 to 0, then from 0 to m, then you equate to a half, but you integrate the corresponding functions. So if we integrate from -1 to 0 and integrate this, we already gotten it in the first part when we were dealing with the finding the interval, and the answer was a third. So the integral from -1 to 0 of this is a third. Now plus 1 over 3, the integral from 0 to m of 2 minus x dx, the answer should be a half. So we are going to have there is a third. We have a third now plus a third. We are integrating this part. What do you get when you integrate 2? You get 2x. What do you get now? Minus. What do you get when you integrate x? X squared over 2. But you have integrated from 0 to m, and our final answer should be a half. So we are going to have a third plus 1 over 3 into, putting the upper limit, we are going to have 2 times m minus m squared over 2. Now putting the lower limit, it is 2 times 0 minus 0 squared over 2, and all that should be a half. So we are going to have 1 over 3 plus 1 over 3 into the other part will face to, this whole part will face to 0. So into 2m minus m squared over 2, and all that should be a half. So when we open this bracket, we are going to have a third plus 2m over 3 minus m squared over 6, and all that is equal to a half. Our LCM of 3, 6, and 2 is a 6. So we are multiplying all through by 6 times 6, that is a 2. Times 6, that is 4m. Times 6, that is the m squared. Then times 6, that is the 3. So because the coefficient on the variable the square is negative, all these ones are moving the other side, and we shall have m squared. When it crosses an equal sign, it becomes a positive. When this one crosses an equal sign, it becomes a negative. So minus 4m. When this one crosses an equal sign, it becomes a negative. But we already have this 3, so minus 2 is equal to a 0. So we are going to have our m squared minus 4m plus 1 when it is 0, and we shall use the quadratic formula to get the value of m. So our m, we are getting this with the am squared plus bm plus c is equal to 0. So a is 1 when you compare coefficients. M squared, a is 1. B is negative 4, and c is a positive 1. So our m is going to be negative b plus or minus under root is b squared minus 4sc over 2a. So m will be negative into negative 4 plus or minus, it is negative 4 squared minus 4 times a 1 for a, then times a 1 for c over 2 times 1, and our m, the value of m will be a 3.7321, and another m will be 0.2679. So after getting the two values of m, which are now the values of the median, you say, remember the median must be that value of m that lies within the range of values of x in which the PDF is defined. So our first m is a 3.7321 our PDF was defined from -1 to 0. It was from -1 to 0, then from 0 to 2. So this 3.7321 is out of range. So we are left with the second one. Our M is 0.2679. So this is you ask yourself, is this one between this and this? Because this was the median interval. And 0.2679 lies between 0 and 2. So this is in the range. Therefore, the median becomes 0.2679, and that is how we get the median. Now, Roman 2 wanted the interquartile range, and we said our interquartile range is a Q3 minus a Q1. What does that imply? We shall follow the procedures and first check whether Q1, you can begin with N. You can begin with the Q1 followed by Q3 or Q3 followed by Q1. But you test the interval within which the lower quartile lies and also the upper quartile lies. For example, for Q1, you will test whether Q1 lies in the interval from -1 to 0. It will lie there if the integral from -infinity to positive infinity of f of x dx is at least a quarter. So if you get an answer which is 0.5 or slightly above 0.5 in the first interval, it means that is the lower quartile interval, and therefore the integral from the lower limits of the first interval to Q1 of f of x for that particular interval with respect to x should be a quarter. You get Q1. You follow the same procedures and get Q3. Then after you substitute in and you give me the interquartile range. So after calculating it, you do not forget to share the solutions, because you need to harmonize them and conclude about which one is the most correct. So finally, as an exercise about the median, we have a question that says a random variable x has a PDF small f of x given by, so our small f of x is equal to, it is kx into 4 minus x squared. That is when x lies between 0 and 2, and it is 0 elsewhere, where k is a constant. So where k is a constant and required is find Roman 1 the value of k, Roman 2 the median, Roman 3 the modes, Roman 4 the mean, Roman 5 the variance, Roman 6 the standard deviation of 2x plus 4, then Roman 7, the semi interquartile range. Then Roman 8 is Roman 8 is the 7th decile, and lastly, the second last is the P75. Then, of course, when you answer all those parts, you become an expert in what we are discussing. So it is very important to have them all. So Roman 10 is the range of the middle 80%. Sometimes they call it the 80th percentile range. So the range of the middle 80% is the same as the range of the 80th percentile. Or they can say, if they don't say the range of the middle 80%, they will say the 80th percentile range. But all those parts require the same analysis. So you work out from Roman 1 to Roman 10, and if you do that, then you will be